Good evening. We're back at it. And tonight we're just going to jump right in. We're going to hit it like hard and fast, and we're going to try to get through this thing in less than the 2 or 3 hours that's been taking me. And I should probably actually stop saying that because then it never actually happens. So better just to not set expectations up front and then don't deliver on them. I'm going to try to do a better job at paying attention to if my camera is recording or not because yesterday it froze after about an hour, and then the last 2 hours of the video were just a frozen me like and then talking. So I've already got my stuff set up, got my project organized. I was prepared today, and we're going to do day 6 of Advent of Code. Today's puzzle is called Guard Gallivant. The historians use their fancy device again, this time to whisk you all the way to the North Pole prototype suit manufacturing lab in the year 1518. Wow. That's a long time ago. It turns out that having direct access to history is very convenient for a group of historians. You still have to be careful of time paradoxes, and so it will be important to avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Just a single guard. They don't take security very seriously. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. You start by making a map, your puzzle input, of the situation. For example, cool, I got it. The map shows the current position of the guard with the caret character to indicate the guard is currently facing up from the perspective of the map. Any obstructions creates desks, alchemical reactors, etc., are shown as a pound sign. Lab guards in 1518 follow a very strict patrol protocol, which involves repeatedly following these steps. If there's something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. Following the above protocol, the guard moves up several times while she reaches. Following the above protocol, the guard moves up several times until she reaches an obstacle. In this case, a pile of failed suit prototypes. Because there is now an obstacle in front of the guard, she turns right before continuing straight in her new facing direction. Reaching another obstacle, a spool of very large long polymers, she turns right again and continues downward. This process continues for a while, but the guard eventually leaves the mapped area after walking past a tank of universal solvents. Okay, so that's her leaving the map. Or I guess if she walked another step, she'd walk off the map. By predicting the guard's route, you can determine which specific positions in the lab will be in the patrol path, including the guard's starting position. That's important. So we have to include the guard's starting position. The positions visited by the guard before leaving the area are marked with an X. In this example, the guard will visit 41 distinct positions of your map. Predict the path of the guard. How many distinct positions will the guard visit before leaving the mapped area? Okay. This is kind of similar to what we did on, was it day 4? But basically we're given another grid, right? We're given another grid of lines, or basically a list of strings, which we can treat the strings as an array of characters because they have strings in C# have the ability to be indexed into. And then essentially what we're going to do is we're going to have some sort of loop where, well, the first thing we're going to do is we're going to have some sort of loop where we walk the grid looking for the guard. And then once we find the guard, we're actually going to need to look for the guard in a couple different ways because the guard's actually represented by this character, but it can also be represented by the less than sign. It can be represented by, it looks like a V to point down, and then I'm guessing, greater than sign, and I'm guessing less than sign is going left. So we need to walk the grid, find the guard, find that character, and then at that point, that's our first visited position. And then we just need to recalculate the guard's position in the grid according to this protocol. And then we're just going to loop over. Again, we loop over the grid looking for the guard. We find the guard. Then we proceed to start looping and moving the guard through the grid in whatever direction they're facing to begin with. So this is kind of a case that would be interesting, is if you find this guard. So before you move, you need to find the guard, and then the first thing you need to do before you move is say, okay, what direction are you facing? We're going to continue moving in that direction, but we need to figure out if the next step is going to be into a barrier or not, right? Because we're continuing to go straight in the direction we're already going, unless there's a barrier there. Then we need to turn the guard and actually go right. So in this case, let's say we did find the guard here. The first thing we would do is we'd say, oh, can I take another step here? No, I can't. I need to turn to the right, and so I'd actually go down. And we just kind of keep going that loop, right? So once we move here, then we say, okay, is there something in front of us? No. Okay, we go here. Is there something in front of us? No. Go here. So it's just going to be a loop. Okay, so let's start with parsing this thing into a grid, which we kind of already have done that before. So we can go back to 4, and we can all probably actually you can probably just actually do this again. So let's get this grid class. There's actually a lot here we can probably reuse because we're basically kind of repeating the same idea here. So this method will come in handy. That's logic that we can use. We don't need this. We don't need this. We probably do want the directions, but we really only need these 4 directions because the guard can only move straight 90. They can only move a 90-degree angle, so we only need these 4 directions. So we can get rid of these. Let's see. We don't need to find Xmas. It's not necessary. We don't need to check if we found a word. We don't need to verify if it's a valid Xmas. It will be helpful to know if we're off the grid, because that will be something we have to check for. That'll be something we need to check for. Is basically, hey, did we move is the guard now off, or is the guard off the grid now? Okay, so let's, missing a parentheses here. Yeah. So we got off the grid, we have walking the grid, we have the grid itself, we have directions that are important to us, we have some ways to represent a direction just fine. We're going to read all the lines. And we are going to now say var grid equals new grid of input. And so the first thing we need to do is we could probably, it's almost like the grid should know the guard's starting position from the inception, right? It's almost like we should have a constructor and we should have a property that's like card because all I'm really doing is I'm just verifying that logic works for finding the guard, and I'd like to be able to test that. So I think what I'm going to do well, they didn't call this a grid, they actually called this a map. So let's actually make it domain var map walk, or not walk map. And let's go ahead and create a test class. There, in here. And class map test. Test public public async task map maybe something like get guard position when called it should return because we're not actually gonna, I mean, we're not, yeah, I'm just gonna say, I'm gonna have it be a property. It's gonna say guard position when called it should return guard's position on that. And this is probably, like, one might say this is silly, but private read only private read only, yeah, string array, that's fine. I'm gonna call this sample. And this can be actually use collection initializer. And I kind of prefer it if it looks like that. Camera hasn't froze, so that's good. and okay. I think I also want something in here that's like private, read only. Do I want it to be a string? What do I want it to be? Because I basically want to have something here that identifies um the guard characters, right? So, and I want to be able to basically reference not a string, but like an actual C# symbol that I can reference as like guard facing right or guard moving up, guard moving down, guard. Yeah. Yeah, actually, the guard's position isn't even just as simple as this. Like, the guard's position actually has, like, guard, a record, guard. Yeah, it has a direction. Um, guard, position. So it has a row index, has a column index, and then it has a direction, but it doesn't have this. It has um what do we want to call this? Guard facing. I mean, it is a direction. Maybe direction's a bad name for this. Maybe it should be move. Um, movement. That maybe it should be movement. Movement. I don't know. Does that make sense? Movement, and then this becomes movements. No, I kind of like move. I kind of like move up, move down, move left, move right. This is why it takes me 2 hours to do these things. Moves. And then record. Record direction. Which just has a string value, and then up, down, left, right. Let's see. They're representing up with a caret. We can do characters. These are actually this would be down, would be I think they're using a V to do down. Ugh. Oh my gosh, I'm just going to copy their V. Do this. And then they're using this for right. is for left. Okay. Then we can have that says private read only. Only directions. Okay. Yeah. And then what I said I wanted to do was I basically want to have a constructor like this that says public map, takes the input, public yeah, I want a public park property of guard position that just has an init that init, and then I want to say public map string input oh whoops, I already declared that. Yeah, what I actually want to do is I want to say guard position equals, yeah, find guard. If cell is not var character if oh, I need to turn off Mr. Copilot here is trying to help me a little bit too much. This is what I was going to do though. I was going to walk the grid. Guard position starts null. I'm going to walk the grid and say if I'm going to walk the map. Sorry, walk the map, and I'm going to say if underscore directions dot what is it? Have a contain. Yeah, contains new character. turn. If that's no, if that is, if is false, and we're gonna say, we're actually gonna say are possible guard. This is kind of, I don't love that because I don't love these calling these directions. They're more like guard symbols. But I want to be able, when I hand back the guard position, I want to be able to very easily say guard is at row index, guard is at column index, guard has an up direction. So I'm actually going to default this to new guard position. What am I going to call it? I'm going to call it oh, this shouldn't be moved. This should be direction. Yeah, there we go. And then we're going to call this, I'm just going to default this to -1, -1. Direction. I'll just put like an X. This will essentially just represent like unknown. Yeah. Okay, so now when my grid is constructed, I have a problem. What's my problem? Oh. So let's do private read only string array our input equals and everywhere where it references input, we need to now say Okay, so then what we should be able to do is in my map test now, I should be able to say var map equals new map, example map, and then I should be able to say assert dot that map dot guard position dot is equal to, and then I can pass it a new guard position, and let's see, he's at 0, 1, 2, 3, 4th, 0, 1, 2, 3, 4. It's on the 4th column. He's dot up, and he is, what is it? He's 0, 1, 2, 3, 4, 5, 6. It's at row 6. Oh, I'm gonna wait this. Go ahead and build. See, it takes me 30 minutes just to get to a point where I'm writing a test where I find the guard position, and other people are already done with this. Basically, what that means is that I would not be an effective object not set to an instance of an object. Well, why is that? Let's see, debug. Let's make this bigger. I always forget I can make it bigger because I don't need to look at the puzzle anymore. I just need to solve this problem. My camera hasn't frozen, so that's good. Something through. Something in that walk method is throwing input dot length. Is it the imp? Oh, yep, it is. Let that be a lesson for you. Needs to be set before I try to find the guard. And we don't need to pass it because we can just operate on it right there. I don't know if this is a good... It almost feels like, hey, if you're going to do this, let's just remove the prop. And let's not do it on object creation because it could be expensive. I mean, I don't think it's an expensive operation, but it could be. Let's make it a method. Get guard position. Oh, am I still debugging? You can stop. When called, should return guard result equals map dot get guard position. What? Ugh, did it again. For whatever reason, sometimes when I'm debugging things, one of my files gets like locked up. And then I can't do anything with it. Okay. Let's try again. Build it. Nice. Okay, so we've got the guard position. Cool. Now we need to do our walk-in. So we are basically going to have another method that's called public. We could say public list of guard position. I mean, it really can just be an int. Get or count visited predict visited or predict distinct positions. For now, just return 0. It'll stop yelling at us. And this is actually our result up in our program. So we'll say map. We'll say var initial position equals map dot get guard position and var none of positions visited or of positions visit equals map dot detect the guard will visit this was the reason why I was trying to not expose a public method to do this, because it really seems like that probably, like the map is returning that out to the caller, and then the caller is passing that back in to this method. Um, so I almost personally almost feel like now that I know it's doing the right thing, I almost feel like I don't need it to be public. And it can just be consumed within this guy. Right? We can say var initial position var current guard position equals get, like that. And obviously now my test, make that private, and then obviously my test is no longer going to be needed, which is fine, which is probably fine, because it's really, we're going to test that logic through the testing of the public method, which is the actual work. So we can say var current guard position equals that, and then this is where we're going to start walking. But in this case, we don't want to do this walk, because this walking the map is literally going we actually want to, I guess we want to patrol the map, right? And so that's going to look different. We still need to loop though. So maybe we say while is I kind of want to say while is on grid, and then I want to give it the current guard position. Yeah, I actually want to say something like current and then I want to say position dot row index position dot well, maybe I want to keep this kind of agnostic of the guard. And just say, I don't know, that just looks nice, don't it? What if I did private I'm just going to change it because I honestly don't know what part 2 is going to have me do. So guard, position, position. This is going to be position dot row index. Position dot row index. Position dot column index, and then position.column index. But I'm going to invert this so that I can say is on grid, which would mean the row index needs to be greater than -1, meaning it's 0 or above. The row index needs to be less than this. And these all become ands. And we say position.column index is again greater than -1, and column index is less than this. And this becomes so while is on grid, we are gonna do some stuff. So we're gonna say var next guard position is going to equal current guard position with, which is this nice little record syntax that we can do. We need to know what direction it's traveling. So we could actually make a little map that says private private read-only movement map equals new dictionary. It's going to be of type direction and then move. Oh, and we can actually do a collection expression here. Actually say here we go. And then down here we'll say we can say direction dot up is going to be equal to move dot up. How do you? I can never remember how you initialize a dictionary. I did it yesterday. I did it in here. Puzzle. No. Update validator. So yeah, so it should be just like this, right? Okay, so let me try doing it this way. New. Yeah. What the hell? Direction up equals move up. And then direction down. Direction down is move down. Direction left is the same as move left, and direction right. Uh-oh, am I freezing? No? Okay. For a second there, I thought I was. Move dot right. And now that I have this, I can actually derive these lists by saying movement math dot this. I can say movement map dot keys dot to list dot to array. Oh, well, yeah, this can be static. Private static. That's fine. That can be static. Values. This can also go here. We can do the same thing there where we say movement map dot keys dot to array like that. And these can also, I mean, this could also be static. There's no reason they need to be tied to the instance. So why did I do all that? I did all that so that I could say bar next move equals current guard dot equals movement map current guard position dot direction, like that. Movements map's probably a bad name in this context. Movement dictionary. And then what we can say is we can say row index equals current guard position plus next move dot x offset, like that. And then we can say column index equals current guard position dot column index plus next move dot y offset. Then what we want to check is we want to say we want to basically make sure that it's not we want to say if we can say if is blocked, next guard position I think if it's blocked, we're just going to turn the guard and then continue. So what does the block method do? Block method is going to say private is blocked, guard position, and it's basically just going to say return input position dot row index position dot column index is that. So if at the next position there's a pound sign, then we know it's blocked. In which case, current guard position is going to equal current guard position with direction. I gotta fix that. It shouldn't be lowercase. Yeah. In which case I can say equals new direction and bar new direction is going to be equal to turn right current guard position dot direction and again I think I'm private bool is turn right I'd kind of like this to read more like a sentence. I'd kind of like this to be like, while current guard position is on grid. But, okay, so what the turn right method does is basically it's going to get us the new direction, because the new direction is going to be if I'm up, then I go to the right. If I'm right, if I'm already facing right, then I need to go down. If I'm already facing down, then I need to go which in that case, I think this can just be a return guard position dot direction switch, and we can say I can never remember the syntax for switch C# expression. Hello, look, that's the, this is like exactly what I want to do. That's fun. I can say guard position dot direction. Isn't this constant? Or is it not? It's not a constant value because it's a record. Well, that's frustrating. But I can do this just like this. I can say if guard position dot direction is direction dot up. Did I change the name of that? Oh, I guess I can just do, I can't pattern match it on it. I can just do equality on it. Should I not? Maybe I don't need that actually. Okay, so if it is up, then we're gonna return direction dot. If I'm up, I'm gonna turn right, so I'm gonna go right. If guard position direction is equal to direction dot right, then we return direction down, and then if guard direction dot direction equals direction dot left. Oh no, down. Down. Then we return direction dot left. Something makes me feel like there's a better way to do this. And then if not if that, then we just direction dot up because we basically come full circle. No, I don't want to convert that yet. So turn right. We can make this static, which is fine. So he's blocked. So we want to turn him. We're not going to change this index. We're just going to turn him. Then we can say if it's not blocked, var count equals 1. And the reason we're starting the count at 1 is because we know he has a current place on the grid, or we're making that assumption. he has a distinct position, so that counts. His current position counts as one. And so then what we'll do is if we get down here, his next position is valid, so we'll actually move him there. So we'll say, oh, we also need to, if we get here, we need to continue because we just want to keep looping. We just want to change this direction. Then we can say, if we get down here, we can say current guard position equals new guard position. Equals next guard position, and we can say count plus plus. We can return count, and I think that will get us to where we want to go. I think. Okay. We're at 1 hour and 6 minutes. It should return expected count, which in this case should be 41. I'll honestly be kind of surprised if my test passes because I feel like this is missing something. So we keep looping as long as it's on the grid. We get the next move based on the current direction. We calculate his next position. We check to see if that next position is blocked by something. If it is blocked by something, then we can't advance him. We can just turn him. And then we continue and then come back. If it's not blocked, then we just go ahead and move him, and that counts as a unique position. Yeah, I don't know. Let's run it. Only one way to find out. But found 6. Okay. We're way off. All right. Let's just kind of step through this then. And let's bring up our test over here so we can see our example input. And let's debug. Make sure we get back the initial position we were expecting, which should be like 6-4 and up. So an initial position of row 6, column 4, facing up. Yep, 4, and then direction is up. So then we should go into this loop because he's not off the grid. Should get the next move, which would put him here. Okay, and then we're gonna say, is it blocked? And it's not blocked. We go here, and we increment it. We basically want to get to, we need to get all the way to index, row index of 1. Hold on, is it blocked? What's the current guard position? No, we're doing something wrong because it looks like we're always moving the column, but we're not moving the. Did I have this backwards? I think I should be adding. Yeah, I think I have these backwards. Stop. Dot y offset dot x offset. Uh, 3 on this. So we got 45. Okay, so I was in the right direction. But we're counting too many moves. Okay. So let's debug this again. Debug. Okay, so we'll say current card position. 3, 2, 1. So it should be here now. And then on the net, it should be blocked. So then we're going to turn right. So the next time around, this should stay the same, but the position should change. So, play. What just happened? Did I break it? That was weird. Yes, now we're going right. Eight. Now we should go down. And we should go down till we get to 7 or 6 again. Okay, and then now we should turn. Oh. Now we're going right. So here. Oh, we shouldn't count that. So we're going over that spot more than once. So Yeah, this is where we should have like a. We should actually, instead of just having a count, we should have like Okay, so we should have var var new var unique positions equals new hash set, and we'll have a tuple of int and int y. You know, I've kind of been referring to row and column backwards, haven't I? Column should really be my x, and row should be my y. Oh, whoops! I need to add a tuple. I wonder, could I just use a hash set of guard position? Um, guard position. Why does it keep doing that? It keeps getting like, oh, my camera froze. Okay, I'm back. I don't know what that's about. I had to restart my whole computer to get the camera to come back alive. I'm not sure. I'll have to do a little bit of troubleshooting on that after we troubleshoot this thing. So I ran this just a minute ago. This still fails because this is not going to work because the I think the direction is different whenever we hit that spot again. So what I actually need to do is I need a hash set of int x, int y. And this is going to be guard position dot column index. Hopefully my camera stays unfrozen for a moment here so we can get through this. Column index current guard position dot row index. Current column. Yep. Add those. Use collection initializer. Oh, yeah, I see what you're saying. see what you're saying there. And then down here, we'll say current guard position dot column index, current guard position dot row index. Now let's try. There we go. Yep. Okay. So now we have our unique hash set. And we're getting 41. So now let's try to run this against our actual input. So we're going .NET run project 06. Did I actually? Yeah, I have to. Okay. What do we call this program? Guard. And then this is going to be 06. But what? No. Let's see. Is blocked. So why? Why would we get there? This is just an order of operations thing. I think I can get around this by changing this into a do while. I don't think that's the right way to handle it, because if you had a case where the guard didn't start on the map, but that seems like it, then the problem would be kind of mute. Well, how am I getting there then? I shouldn't be able to get there. Is on grid. Oh, I'm an idiot. No, that's, yeah. While I don't understand how it's on the grid. It's on the grid, and then we move next. Now it's off the grid. So I think actually what I'm going to do is I'm going to make this just a true. And then I'm going to say if is off, is off, if is, well, now I don't want it to be is on grid. I want it to be is off grid. So we're gonna go, this would be a break. Now I want to say is off grid, and I want to say is less than 0, greater than that, less than 0, greater than this, and these all become 4s. And then we say is, if is off grid. Oh. Let's make sure our test still passes. What? Oh, not current. Next. Yeah, okay. Now we're gonna and we will check our answer. Hey, nice. Okay, you know what that means now. Part 2. Part 2. Oh, let's also add private async task that will return a string. Get puzzle input. Return the file.read all lines. Excuse me. App context input.key. When called, the puzzle input. When called, the sample input. What was this? I forget what this, how much this was. There was like 4. And now we have a test. No. Oh, we didn't. The camera's just being kind of sluggish, isn't it? It looks sluggish down here. I'm wondering if it's sluggish on the stream too, but at least it's not freezing quite yet. I wonder why it's doing that. I don't know. Okay, let's continue to part 2. Actually, I don't want to have to worry about the camera anymore, so I'm going to switch. I'm actually, one sec, I'll be right back. Okay. Am I frozen? No? Maybe my computer's just having a hard time keeping up. I'm actually gonna quit that. And I'm gonna shut this down. I turned off Docker, turned off WSL. I don't know, maybe it's just I don't know. I don't usually have any issue with this computer keeping up. Don't know why it's doing that. Anyways, let's see if this camera does any better. I just went and got my less nice camera. Okay, where were we? We're on part 2. Apologies for the interruption there. We are on part 2. So let's get our problem. This looks like it's going to be more difficult. Oh my goodness. Oops. There's a lot of words. This almost looks like it's a whole nother puzzle unto itself. Okay. Oh, actually, I don't need to do all that. I'm going to do it the smart way. I'm going to copy this. I'm going to go down to markdown, or no, HTML to markdown converter. Put that there. Copy. Just put some backticks around this guy. I'm not sure why that converter doesn't handle. This probably adds some time to my puzzle solving too by doing this. There's definitely going to be some more complexity to my looping from just, I haven't even read the problem, but just seeing these maps with the symbols makes me think I'm in for a treat. Okay. We've got our problem saved. Now let's read this problem. Okay. So while the historians begin working around the guards' patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel through the last few months and record the nightly status of the lab's guard post on the walls of the closet. Returning after what seems like only a few seconds to the historians, they explain that the guard's patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. They'd like to place the new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. To have the lowest chance of creating a paradox, the historians would like to know all of the possible positions for such an obstruction. The new obstruction can't be placed at the guard's starting position. The guard is there right now and would notice. In the above example, there are only 6 different positions where a new obstruction would cause the guard to get stuck in a loop. The diagrams of these 6 positions use 0 to mark the new obstruction. A pipe to show a position where the guard moves up and down, another pipe to show a position where the guard moves left and right, and a plus to show a position where the guard moves both up, down, and left, right. Option 1, put a printing press next to the guard's starting position. Option 2, put a stack of failed suit prototypes in the bottom right quadrant of the mapped area. Option 3, put a crate of chimney squeeze prototype fabric next to the standing desk in the bottom right quadrant. Option 4, put an alchemical retroencapulator near the bottom left corner. Option 5, put the alchemical retroencapulator a bit to the right instead. Option 6, put a tank of sovereign glue right next to the tank of universal solvent. It doesn't really matter what you choose to use as an obstacle so long as you and the historians can put it into position without the guard noticing. The important thing is having enough options that you can find one that minimizes the time paradoxes. In this example, there are 6 different positions you could choose. You need to get the guard stuck in a loop by adding a single new obstruction. How many different positions could you choose for this obstruction? Okay, well, so the first thing I'm thinking is we need a way to detect that we've actually encountered a loop. And so the way we know if we encountered a loop is essentially if we've gone over all the same spots. It's not necessarily just knowing we've gone over the beginning spot. Or is it? Is it? I mean, I guess it kind of is. It's like, hey, when we get back to the start, we've gone in a loop. Does that logic make sense? Yeah. Um, and I think the non optimal way to do this is basically to just place the obstruction anywhere there's not already an obstruction, and then run the patrol. But I 100% know there's some sort of algorithmic, like there's a all of this is distracting. Like this is all meant for distraction. Um, there's some sort of algorithmic way that's probably fast and the correct way to do this, but in my mind, the brute force. I'm just thinking the brute force way of um, let's. I'm just gonna try the brute force approach. Because I don't actually know. I don't know the way. I don't know the right algorithm to solve it. So basically, what we're gonna do is we're gonna do this. Uh, so we're gonna have a new method that's gonna be called public int um, identify number of placements for new obstruction. They call it obstruction or obstacle. I think they call it obstruction. Yeah, they call it obstruction. So a lot of this is the same. Um, yeah, a lot of this is the same. Except for we don't. Um, well, first, what we're gonna do. Let's before we do that, the first thing we're gonna do is we're gonna walk the grid or walk the map. Um, this is row, index, column, index, and we're gonna walk it. And now I'll just return 0. And we'll have to say, so we'll say current character equals input row index column index, and we'll say if it's blocked or if it's the guard is blocked, private tool is guard. This is just going to be a char of current character. Return direction. Yeah, this is where I don't really like it. So it's like if direction dot no directions contain current character. What? Directions is an array of. Oh. If it contains new direction current character. So if is guard or is blocked, private rule is blocked char. Character is then we're just going to continue. No, we're just going to return. Otherwise, this is where we want to then do this. Oh, it's 11:30. I was hoping this wouldn't go this long. Okay. So we'll say original guard position. And so current guard position is going to be original guard position. Yeah, so record is value type. So how to make copy? I think just by assignment. Okay, so we don't care about unique positions anymore. Current character is guard. We do need to make a copy of the input. So we'll call it var local map equals input dot to array. Well, now here's a problem. Because the map I want to walk actually needs to be modified. Okay, can I extend this function to say you also take an optional string array that is a map and it defaults to input? So we'll make that null. And then we'll say var map to block equals map or then we'll say this guy, this guy. Well, no, I don't need to do that, do I? Yeah, because I'm just doing the indexes. I'm not doing anything with the actual character values. So I don't actually need to do that. Because up here, oh shit. Okay, so I've kind of created an issue for myself because my map is part of my grid and I don't want to mutate it. But with this approach I have to because I need to place the obstruction, then walk the map or patrol the map. Yeah, all of this logic is based around the map. Just excuse me. Okay, so we will leave this we'll leave this way. Okay, here's what we're gonna do. We're gonna say um, var map we're gonna say var map equals local or input dot to array. We're gonna make a copy. Then what we're gonna do is we're gonna say var map with new obstruction. And we're gonna say map with new obstruction, row index, column index equals new obstruction. What doesn't it like about that? What's the problem? Oh, I can't set it. I can just, okay. So then I can say dot um, replace. No, I want to insert. Insert. Yeah, I need to make a new string. Let's see. C# place character in string at index. Okay. Okay. Our row equals, and we'll say Then we say row column index equals then we'll say map with new obstruction row index equals row. Up to string. New string. Okay. So that's basically us placing the obstruction is what that is. It's fine. Oh. So that's us placing the new obstruction. Then once we place the new obstruction, we need to say bar has loop, or yeah, has loop. And then what we're going to do is we're going to say new grid, new map with this guy. And then we're going to call something called detect loop. That. And then we're going to implement that method. Can it be private? Yeah, it can be private because it's called within the... Okay. And then if has loop, we will count equals 0. We'll do a little count plus plus. And return count. And then this down here is going to detect the loop. So to detect the loop, we're basically going to do the same, very much the same thing. Only we're going to have bar original guard position equals get guard position, and then that's going to be equal to this to start with. Okay, so if it's off grid, we are gonna return false. If If is blocked, that's fine. We'll continue. Don't need to do any of this. And we'll just default this to right, so if it's a block, we'll continue. But at some point, we need to check if the current position is equal to so let's look at that example. So just starting here, right? We're going to go up, turn right, come all the way here, and we'll say, oh, I'm blocked. So I'll turn right. So I'm thinking I can check here, right? So I can say if next guard position equals original guard position, then we know we have a loop. Is that overly simplistic? I don't know. I definitely know I'm not doing this elegantly, that's for sure. I don't really care for having a while true loop here. I don't know. This seems not good, but let us try it. So let's go back to our tests. No, let's go back. Yeah, let's go back to our tests. And let's say got some long method names going on tonight. When given example input, it should return expected count. So example, we will say identify number of placements, and the result in this case should be 6. And then just one time to kind of talk through my thought process here is the first thing we're going to do is we're just going to walk over the grid, and anytime we find a place where we could potentially put an obstruction, we are going to put an obstruction. Then we're going to create a new map, a new version of the map with the obstruction placed on it. Then we're going to on that map we're going to check to see if there's now a loop, or if the guard gets stuck in a loop or encounters a loop with that obstruction placed. Yes. Then in the detect loop function, what we're doing is we're getting the guard's original position, and then we're going to keep track of their current position. And so then what we're going to do is we're just going to have the guard move through the map. And if any time I calculate that the guard is ending up back where they started, I'll return true. If I find that the next guard's movement takes them off the grid, then it's false, because I know they're not in a loop at that point. They've exited the grid. Otherwise, if they encounter a blocked position, we'll have them turn. If they're not blocked, then we'll just keep going, iterating, moving them to the next position and then doing it all again. So that sounds right to me. That's not a good sign. So we've either created an infinite loop or this thing is super, super slow. Okay, let's see if I've created an infinite loop here. So I just want to see. Did we place? Yeah, so we're at the very first. We're still there. Still there, still there, still there, still there, still there. Do we ever get back here? Um, I must be creating an input in that loop because this is a small enough input that it shouldn't really ever. I don't know where did I place a obstruction. should really. We are moving. This one should cause a loop. Yeah, this one causes a loop. So, but I feel like this is where this should hit. Next guard position. It's going to be 3. This. Is off grid? No. Is it blocked? Redirection. Okay. Okay. So what's happening here? Oh, okay. Stop. The current guard position. Found 91. Oh shit. Okay. Well, right now I'm at 2 hours. Right about 2 hours. And I don't feel like I have a good handle on this. Well, that's just always going to evaluate the true, right? Like for every single one, I think the way I wrote that. Yeah, I don't think I've even gone. Yeah, I'm at the very first one. That's true. That's true. Yeah, so that's not working. Um, but the next guard position should. This should hit. Um, yeah, so that hits. Okay, it's one. That should be okay. Next guard position. So this should hit. I mean, that's what I actually want to check. And it just never gets hit. Okay, stop, kill it. Um, I want to set a breakpoint when it reaches this index. So this would be what would this be? This would be well, I can just step through it up here. Here. Debug. And I can just follow this map. And when its place gets down here, I want to. Yep, keep going. We're gonna walk all the way down. This would probably be a good use case for conditional breakpoints, but so this placement should produce a loop. So we step over. We step over. Current guard position is 6-4. Okay, so next guard position is going to be 5-4. Next guard position is going to be 4-4. 3-4-2-1. That's blocked. So we're going to turn. So maybe we need to add this check here. Now we're moving right. Now we're moving back down. Now we're moving back left. Okay, so at this point, it's not off grid, but it is blocked, isn't it? Blocked. So at this point, current guard position equals the original. So stop. If current guard position equals original guard position, turn true. Why doesn't that hit? No. I'm not gonna do that. It's fine. Getting a little frustrated now. Feeling like I don't want to do this anymore. Right here. Okay. So right now we're moving up. So right here we're moving up, and we should get blocked here, which we do. Then now we're moving right, and we shouldn't get blocked until here. Okay. Now we're moving down. And we should keep going down till we hit next guard position 7. Now we should turn and go left. Okay. And now we should go left. Now we should step over here. New direction is up. So this current is 4, 6 in the up direction. 6 or 6, 4. Yeah, 6, 4. So why are these not equal? Oh, it does hit it. Okay. So, where does it get stuck looping next? Because it's getting stuck somewhere. The next one should be here. So, it detected the first one. Now we need to get it when it's one over from that one. Okay. Nope, 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 nope. Yes. So this one they expect to get a loop. It'd probably be easier to debug if I actually mutated the map as I went through this. Uh, yeah. So goes up here, 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 here. Oh, there's nothing forcing it to go back. Uh, so it's not just about getting back here, because if we do that, if we place this and it, well, it's kind of interesting. Every loop transverses back over the start position. How do I detect a loop then? How does this loop go? Here, 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 here. Hold on, did I do that right? Up, right, down, right, 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 right. Okay, so what if I don't check for direction? What if I just say if guard position dot column index equals dot column index and what happens? Well, that seems weird. So it's not just about getting to it. How would I know it's been a loop though? Right? If I visited the same positions multiple times in a row? Does that make sense? I'm having a tough time figuring out how I detect a loop. So I go here, here, here. Oh, let's just. I've been here, been there, been there, been there, been there, been there, been there, been there. All the way around. We come back. Even this is not a loop until we reach this point. Um, Man, yeah, this one's got me pretty stumped. Thinking, okay, yeah, even this. Huh, I don't get it. I felt like this didn't build off of my previous solution at all. So did I just maybe tackle this wrong the first time through here? Hmm. All right, I'm gonna give it 5 more minutes, and if I can't figure it out, it's gonna have to wait till a different day. Um, so what if we think about it like this? If okay, at this point I'm going up. Okay, unique obstacle. First time hitting it. First time hitting it. First time hitting it. First time hitting it. So at this point I've encountered 4 obstacles. Oh, I'm hitting that obstacle again. Oh, I'm hitting that obstacle again. Oh, I'm hitting that obstacle again. Okay, so if I come down here and I say I hit that obstacle, I hit that obstacle, I hit that obstacle, new obstacle, new obstacle, new obstacle, um, new obstacle, same obstacle. So if I encounter the same obstacle more than twice, could I track that as the loop? So new obstacle, 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 um, duplicate obstacle, new obstacle. So that would detect a loop because that's a duplicate. Um, let's go down here and say same thing here. Up, unique, 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 duplicate, duplicate. Yeah, I think that might work. Okay, unique, 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 duplicate, 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 duplicate. Okay. Um, unique, 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 duplicate, unique, unique, duplicate. So would that work? block positions equal to Is it really that simple? Okay, let's try to run it on the real input then. Sure that still works. 4-7, yeah. And we'll say part 2, and hopefully this doesn't blow up. My input is much larger. 130. But now I'm afraid I'm stuck in the loop. No, that's just really slow. 41 seconds. Okay, let's see. So that works, but that is definitely the brute force approach. I mean, 41 milliseconds. Okay, so let's do this. When called with puzzle input, should give me 1304. I honestly, that took me a long time to figure out what the character of the loop was. And I honestly, I can't say that there was anything super intellectual about it other than the fact that I was just looking for commonalities between the loop patterns that they had and trying to see, okay, if I was, I mean, just basically thinking like a person in this maze, how would I identify that I've been somewhere more than once, right? And so I definitely can use the coordinate, um, but that's not super helpful because I can walk over that. I can walk over that without being obstructed. Um, so it's really I'm in a loop if I've hit a coordinate that is obstructed multiple times, and so that's what I'm keying off of. Uh, but it's slow because I know it's slow, and I knew it was slow because I am basically doing almost like a flood fill where I'm just can I place I'll place it here? Is there a loop created? I'll place it here. Is there a loop created? If I place it here, and that's just very brute force. So there's definitely work to be done here where we could optimize this, or I need to think about how I would optimize it. I don't think that's going to happen tonight. Um, so to do this can be optimized, I think. Right now, I'm basically doing. I think the term would be a flood fill. Flood fill. I think that's basically what I'm doing. Flood fill. I think. I'm finding all the places on the map where I can place the obstruction, placing, and then seeing if a loop is created when guard patrols map. There's got to be a better way to do that. Well, the other thing I was gonna say is this is kind of duplicative logic. Yeah, this is like duplicative, and it kind of makes me want to find a way to reuse it. But I'm not sure how to do that in a meaningful way at the moment. Well, actually, I take that back. Um, um, so this instead would be next guard position. Next guard position. Yeah, I'm thinking I could have a thing here that's called private void patrol map. And I'm thinking this is going to have a guard position, call back, and so I'm thinking I'm basically thinking you have two guard positions. That's going to be current. Current. Next. And original. So you've got our original guard position. Then you've got current. That. And then you've got your callback, which takes in the original, current, and next. That. You're right, it doesn't ever return. Um, Trying to think of there's a way I can do this that makes sense. Um, the callback should really be responsible for exiting it. I guess because if I break out, yeah, let's do this. So Return false. Um, this is making my brain hurt a little bit at the moment. Do all my tests still pass? Yeah, it's almost like I want to actually define like hooks, right? So like, oh, when he is blocked, what do you want to do? Oh, when he is I don't think that really helps the fact that it never returns though. Maybe I just need an explicit call to is off grid. And I'd basically be able to say control map that's got uh, original point and you don't have need for this. Say copy, but instead of initializing, you do this. And then you'd say unique positions dot add original dot column index original dot row index. Let's be a tuple. Tuple. That's all this doesn't, you don't need this. I don't know if this will actually work now that I'm kind of thinking about it. That's kind of interesting. The callback could return the new current. Like this. Okay, that was a waste of time. I'm gonna put it all back. um, Crap. I fucked it all up. Okay, this was actually okay. So delete this. Or current equals get our position. This was like an initializer that looked like I should have committed current guard position. Let that be a lesson. Okay. I am off. Yeah, I'm gonna have to watch some other people solve this to see how this can be improved because I don't off the top of my head I just don't have any idea how I would do it differently. Cool. Okay. Let's update the README and then we'll call it a day. Part 2 is low. Part 2 is for I kind of brute force. This is which actually isn't the first time. Last year there was a problem that I had the solution, but I basically had to let my machine run for kind of an extended period of time, like 20 minutes or 30 minutes or something like that. And I had to use like a parallel for loop, and yeah, so I mean, guess at times you can get away with brute forcing things, but for things like this, you know. Okay, the README's been updated. My problem has part 2 in it. Okay. We got my test written. Oh, I need to pull these into separate classes. I was pretty close to giving up there for a second, to be honest. When I said I was going to give it 5 more minutes, isn't that the way though it is, man? Like, it's always right before you want to give up. In anything in life, that's when you figure it out. Okay. Get commit in feature solved day 6, part 1 and part 2. Alrighty. That is gonna do her. I gotta get up early. I gotta get up in like, well, I guess not super early. I have to take my car and drop it off to get fixed. But yeah, I'm glad I stayed up. I'm glad I got this done. My computer didn't freeze, or my camera didn't freeze up again. So I'll probably stick with this camera when I stream. And yeah, if you watch this, I hope you enjoyed it. I hope you may have got something from it. Maybe it helped you solve the puzzle at some point. Maybe you're